This last method of factoring we're going to learn is called quadratic form, and it basically is about recognizing a certain pattern. So the first thing I'm going to do before I even attempt this problem is factor out the GCF, which in this case would be 3p squared. So it looks like I'll be left with p to the 6, 5p cubed, and 6. So even though this says p to the 6, and we're really used to just dealing with things like p squared, if you recognize this exponent is double this exponent. So we actually can rewrite this in a format that we're familiar with, which basically means we can rewrite this as a squared. So we kind of use this idea. So we're going to call p to the third, the middle term, we're going to call that a u. We typically use a u because that stands for the phrase used substitution. So we're kind of inventing substitution to help us get through a problem. So we're going to let u equal p cubed, and that would make p to the 6 the same thing as u squared. So if you take p to the third and square it, you will get p to the 6. So that's the first thing that we want to do, is we want to change this into u's. So p to the 6 we're going to swap out for u squared. P to the third we're going to swap out for u. And then we're going to factor this like a normal quadratic. So factors of 6 that make 5 would be 2 and 3. And then instead of circling it saying, oh, we're done, we're going to go ahead and swap back those u's for that p cubed. So we'll go ahead and finish it up by writing p cubed plus 2 and p cubed plus 3. Now this is really an optional trick. You could actually do this without using the u's at all. It's just, for some reason, just using the u's and changing it to squared makes people feel a little bit better and makes it a little less scary. So we'll give it another shot here. The GCF is definitely going to be 4n squared, which leaves us with n to the 10th, 8n to the 5th, and 12. So again, I pick up on this pattern that I noticed that we have a trinomial, and this exponent is this one doubled, which means I'm welcome to use that quadratic form or u substitution. So we let u equal n to the 5th, which would mean that u squared is n to the 10th. Bring down the GCF, but we're going to swap out here a u squared minus 8u plus 12. So then we can go ahead and factor that quadratic into u minus 6 and u minus 2. And then my last step is just going to be to change the u back into n to the 5th. So be on the lookout if you happen to see this pattern where the largest exponent is doubled the middle exponent, because chances are you can use that u substitution to help you factor that problem. So we have kind of just a little bit of mixture. We want to go through and be able to classify what method would probably be best for each type of problem. So if you look at letter A right off the bat, you should see cubes. So we're going to use the sum of cubes formula. Letter B has 4 terms, so we should try grouping and kind of reevaluate where to go depending on that answer. Letter C, I don't like to have the leading coefficient as negative. I like to have it the other way around. So what I'm going to do is I'm going to make 625 come first and then change it to minus 16n to the 4th. I just like to have a positive in the first spot. It just makes things a little bit easier. And 625 and 16 are perfect squares. Oops. So you do have a difference of squares. Letter D definitely has a GCF, so that has to be the first step. And then when something is 2 terms, chances are if it can factor further, it's a difference of squares, or in this case, a difference of cubes. If it's z plus, it'd just be sum of cubes. So what I would do is factor out the GCF and then ask yourself if you have one of these scenarios, and then you can continue working. For letter E, I would definitely try grouping and see if you get lucky. And then for letter F, we definitely have a GCF, so that comes first. And then I'm just looking here, if I pull out a w squared, that's going to change this to w to the fourth and w squared. So I have this pattern where this exponent is double this one. So I'm going to use, I'll just call it the U method, since we will be using U's. So I'm going to go ahead and pause the video. I'm going to try factoring in my way, and then when you're done, you can unpause and we can compare work and answers. All right, so hopefully you're able to follow the sum of cubes formula okay. For letter B, it did end up working out, the grouping worked out because the parentheses matched up, but hopefully you caught that there was a difference of squares in your answer, so that could be factored further. Kind of the same thing happened with C. After you took the square root of each term, you still had yet another difference of squares. So this parenthesis actually could factor further. And then for D, it turned out to be a difference of cubes. So we went ahead and used the difference of cubes formula to factor that parentheses. And the grouping worked for E, so that was nice. And then for F, we ended up finding out that it factored very nicely into u squared minus 5u plus 6, and then we were able to factor that even further.